Hello everyone. In this video, I will introduce Solana Agent Wallet, a local wallet designed for LLMs and autonomous agents. The key idea is simple. Agents should be able to request blockchain actions, but they should not directly hold private keys or have unrestricted signing power. Solana Agent Wallet creates a local, controllable, and auditable signing boundary for agentic actions. It keeps the private key on the user's machine, applies policy checks before every transaction, and records what happened for later review. It also uses passkey-based authorization to protect policy changes, so an agent cannot simply increase its own permissions. Traditional wallets are designed for humans. In a normal wallet flow, the user manually confirms each transaction, the wallet app holds the signing capability, and the human acts as the final decision maker. But in the agent era, the interaction model changes. An agent may run tasks in the background, it may generate transactions automatically, it may receive complex instructions from users, websites, tools, or external data sources. This creates new risks. First, the agent may misunderstand the user's instruction. For example, a vague payment request could be interpreted incorrectly. Second, prompt injection can manipulate the agent. A malicious web page, document, or tool response could try to convince the agent to transfer funds or call a dangerous program. Third, private key exposure is fatal. If the key is leaked or given directly to the agent, then all higher-level policies become useless. That is why we need a dedicated agent wallet layer between the agent and the blockchain. Solana Agent Wallet is a local signer service. Instead of giving the private key to the agent sends a transaction request to a local API. The wallet service then checks that request against a policy engine before signing anything. There are 4 important design points. First, private key isolation. The private key is unlocked only inside the local process and is never exposed to the agent. Second, policy verification. Every transaction must pass whitelist rules, spending limits, and simulation checks. Third, strong authorization. Policy changes are protected by passkey, so sensitive settings cannot be changed by the agent itself. Fourth, full traceability. Both confirmed and rejected requests are written into audit logs. This design turns the agent from a signer into a requester. The local wallet remains the authority that decides whether a transaction is allowed. Now, let's look at the main security features. The first one is simulation first. Before sending a transaction, the wallet simulates it and estimates the actual balance change. This helps measure the real spend instead of trusting only the agent's request. The second one is daily limits. The wallet can cap how much value can leave the wallet in a single day. Even if the agent makes repeated requests, the policy engine can stop spending after the limit is reached. The third one is the program whitelist. Only approved Solana programs can be called. For example, a simple SOL transfer requires the system program to be explicitly whitelisted. The fourth one is panic mode. This is an emergency switch. When panic mode is enabled, all automated transaction requests are rejected. Together, these controls reduce the blast radius of agent mistakes or malicious prompts. Security is not only about blocking transactions, it is also about understanding what happened. Solana Agent Wallet records audit logs for every execution attempt. The log includes the agent's intent, the final status, the Solana transaction signature if the transaction was confirmed, and the actual cost. For rejected requests, the wallet records the error reason. This makes it easier to understand whether the request failed because of a whitelist rule, a daily limit, simulation failure, or panic mode. This is important for real agent workflows because automation must be transparent. If an agent is acting on behalf of a user, the user should be able to review what the agent attempted, what was allowed, what was rejected, and why. This project is currently a practical local MVP, but there are several directions for future improvement. One direction is more granular policies such as per-token limits, per-recipient limits, and program-specific rules. Another direction is multi-profile support. Different wallets or different agents may need different risk profiles. The dashboard can also become more powerful. with richer risk alerts, better analytics, and clearer explanations of rejected transactions. Finally, the wallet can integrate with more agent frameworks, so developers can plug this local signing boundary into their existing agent workflows. The long-term goal is to make autonomous blockchain actions safer without removing the flexibility that makes agents useful. Thank you for watching. To summarize, Solana Agent Wallet keeps the private key local, turns agents into transaction requesters, applies policy controls before signing, and records each action for auditability. This gives agents a safer way to interact with Solana while keeping users in control of the signing boundary.